Here we go. Let's go live. What have we got? This is my first attempt at doing any kind of development. That's quite bright. I'm going to have to get a ring light there. This is FujiNet development with AppleWin. And I bet I'm the only person who comes back to watch it. So, I am currently working on getting AppleWin. This is my AppleWin code base, which I have forked and is using Smart Port over SLIP, a protocol that we have designed to allow us to do connection between AppleWin and FujiNet device via SP over SLIP. And at the moment, the network library works, but we don't have disks working. So what I'm going to do is put this stream into Discord as well. Down here, Apple, I'm in. I'm going to do my screen. I'm going to do screen. I'm going to do screen 1. And I'm going to go live. Just for the hell of it. For lols, I am live. I don't turn on my. Right. I change the window to be. Oh no, I'm going to have to do my screen because then I can't do the face stuff, but that could be fine. That's fine. That's fine. It's just screen 1. Noise suppression powered by so and so. Right. So we very quickly have got some commentary from. Oh, that's in there. Some commentary from Oliver on the ways that we can move forward. The problem we currently have is that, let's fire this up, start up AppleWin. This is AppleWin. I have changed it to put Smart Port over SLIP stuff here and enable listener. So one of the problems here is that when I start this up like this, okay, now that's, I don't want that, let's eject that and let's restart that. So if I start this up, Control F2 and then do PR-5, I get FujiNet error. And the reason for that, this one I do actually prefer this window for doing this development. The reason for that is that I think FujiNet's coming in to here. Sorry, the AppleWin's coming into here, coming into this firmware, and it's executing this, and it's immediately just doing this error. So one of the things we want to do is to debug that and see whether or not that's true. Lols, I am streaming dev to both Discord, YouTube, yeah. Right, see if anybody bothers joining. Okay, so yes, we're coming into here and it's just doing an error. So I do have a little notepad which I make notes on here. The code that I am loading in here when I do this development is on slot 5, which is why I did PR-5. What I can do is come into here, I think it is C500. And there we go, we can see C500 at the top here. C500. This is the. We can do a breakpoint. It hasn't loaded the code. Interesting. So none of that is right. So if we put breakpoint at C500, I happen to know that breakpoint at C508 and a breakpoint at C51A. What we should also be able to do is find the entry point, which we'll do in a minute. 7 here. I'll go by. No, that's not going to work. So let's put my clean disk in. I've got a clean empty disk. And I'm just going to reboot. Yes. So that comes into here. Interesting. Right. So it comes into the clean and it comes into here. So if we go UC500, we should now see that, no, it's not. Still not. DC08D. Okay. What's that? I'm running the listener, aren't I? Oh, that's the listener. So definitely loaded. For some reason, it's not loading. Right. So maybe if I hit tab. Okay. Interesting. This is not what I was getting before. I think maybe because nothing's connected to it, maybe. Let's have a look. So I'm going to, yes, maybe that's it. Let's start this little thing again. Kill that. Right, this is my FujiNet PC. It's running via, that is what AppleWin will connect to. Now I'm going to fire up AppleWin again. Yeah. The list. Oh, there we go. There's undo. Hello. I can hear you well. How are you doing? And what I need to do is probably add an audio. I can hear you. Yes. I can hear you. I forgot I've got push to talk on this. Just a minute. I'll turn that off. Video and voice activity. Right, you should be able to hear me now without me having to push the button. Yes, good. Right, and also what I use it for my D&D sessions. It's good for when I'm doing D&D because Tanya's in the background. She might talk to me about stuff and I don't want it to be coming straight from that. Let's do Discord. I'm just setting up my OBS. This is just practice really for me to just set some, no particular reason. Let's say Discord. Oh. Mic, Discord mic. No, that's not what it is. All right. Go on. Yeah, exactly. That's what I'm currently doing. I can just turn it straight. I just click the button when it's finished and turn it to a video. So, audio input capture, delete that. It's not an audio input. It's an output that I want to capture. Audio output capture. That's going to be Discord. And that should
figure out what is the Apple control reset. I'm guessing or hoping that there's like a menu somewhere in AppleWin that gives me the key, the special key.
Control F2 is the AppleWin control reset button.
Control.
Yeah, I had to learn that one the hard way.
Oh yeah.
There we go. Right.
I'm gonna write that down.
Yeah, I had a few shortcuts. Right. So what I was going to do here is I've got the FujiNet PC. Your stream is still running. Yes, I know that. Let me get the FujiNet PC output up. There's about a dozen windows, so I've got to get it all sorted. Right. Okay, here we go. So that is output from FujiNet PC. Let's move that in size down a bit. And then this is AppleWin. So AppleWin's got a clean hyphen empty.
Oh, it has a
Yeah.
nice. It has a nice. You're doing this right. You're running right now on Windows. I've
Yeah.
just been exclusively using the Linux one. It
Yeah.
has a fancy little splash screen there on Windows. You just get black.
Yes, it does. Yeah, there's a little bit of difference there. Right. So if we
But
start this up,
yeah.
I should get Bitsy Pro, which I do. Right. So, and then what I've had here is a bunch of packets, and I need to start working
Oh,
out from the spec what those things are. Now, what I was seeing before. Oh, this is what I wanted to do. So that right, okay. So I need
let me
to.
ask you one quick question too. What? How do you make that Bitsy by disk? Or do you want to consider just popping it up on the Discord so everyone, if anyone's following along like me, will have the exact same
Okay, I
kind of
can do.
environment?
It just is using McBitsy from the Apple Tools directory. I mean, I can go into that. In fact, that's so I did it from here, which was no, actually, it wasn't from here, but it doesn't really matter. The the McBitsy is part of Apple Tools here.
Yeah, let me jump over to the Apple Tools. I didn't have much. I did. I was able to go in and create the HDD bin and do the replace basic. And now when I turn on my AppleWin, it pops right up to your HDD bin, which is cool.
Good.
You know, it
Oh
auto
yeah,
boots
yeah,
it.
yeah. That's the
Yeah,
stuff that we
yeah, you
fixed.
guys worked that up.
I've,
Yeah.
yeah, cool. The
Oh, so you just do make Bitsy, and
yeah,
that
just
alone will do it, or
with
oh
the
yeah,
name of the
create an
file
API.
and the name of the volume that you're going to give it. So that /clean that you saw is because I've put the word clean at the end there. So you can see on my screen, except, oh no,
So wait though, what is volume
it's just what it mounts as. So
name?
let me show you. The volume name is what it'll appear as
Oh,
when we're on this screen with /clean there. So it can be, that's the disk name effectively. So,
got it. Yeah.
all right. So when you do, when you kind of do, have I got it on this? ACX, help. Yes, I have. Yeah, increase the, can I increase the, yes, I can. Okay. So I can do, so for instance, I can do ACX. I think it's, do I have to do -D? And do I do disk? So if I do ls -D clean.py, it's just a little bit small. I've made it big so people can read it, but it's a bit pointless. ACX, and I think it's ls -D clean. I don't know why that's not coming up with clean dot. No,
Yeah. Okay. So if I eject this, and I'm
because I haven't
going
got
to
it on here,
put
that's why.
in
The Apple PO, and I can do my ACX list -D, and then just do clean empty. So when we use McBitsy, which is just using the Apple Commander Java stuff,
yeah,
you can use that to create a disk, right? And all that this shell script does is front that and put a few things on it. ACX is really
yeah,
useful for AC and ACX. ACX is the improved version; it's the extended version. Uses better tooling, but ACX list then the disk name. And what you'll see here, if you watch my stream, is that it's got the name /clean, and that's because when I did McBitsy earlier,
yep,
I just used the word clean at the end of the argument there. That so the script just
yep.
takes the name that we give it, and where did it do that? There we go. That's the disk, and then it source is the volume name. So we rename the disk with volume name there at the end of the script, and volume name is just the argument that you give it. So it's just a really easy way of giving a volume a name. So I've been creating names like test underscore and then the name of whatever the application I'm doing. So test HTTP bin is what you'll typically see and things like that as the disk names. So what we've got here, and I'm going to reset this. This is what we want to debug, why it's doing this thing and if it's going into ProDOS. So
So and is it tab to? Oh yeah, tab is the new
tab
volume.
will move it over, right? And it's just not working properly because I've not been giving it the right values. So we want to find out where that's coming in from. So I'm going to kill that. What's really nice is showing this. You can see now with the changes I made for Windows, this now goes back to listening for an AppleWin. That was all the work I was doing over the last couple of days.
Yeah.
So it is now sitting there going.
And it'll sit happily until you start Apple A2Win again.
Yep, exactly. So the Fujinet PC for Apple is just sitting there waiting for an AppleWin connection. That's all it does. Once it's made that connection connected, it's fine. And then if you kill the AppleWin, it goes back into this. It kills the thread that was listening. And as you can see, it says, "Oh look, I'm exiting that thread," and it restarts. Right. So we are now waiting. I'm now going to fire up AppleWin, which is here. And that will start the connection. So now in the background, they've communicated with each other and they've done that initial transaction of telling me what devices there are. So you can see here it's done 9 drives. We know that there's 1 to 9, and that we haven't done the names.
Yeah, I wondered what that 9 was. Okay, I thought that was identifying itself. Okay, but you're right, 9 devices.
Yeah, because it's disk 1, 2, network, clock, CPM, and everything else.
CPM.
Right. So now what we can do in this is set up some breakpoints. So F7. Oh, that is interesting. Why did that just throw a few more packets there? Bad command OA. So OA is the reset, I think. So a reset was sent for some reason. I was not expecting to get the disk stuff yet. Unit 9, bad. There's just got a whole bunch of, so for some reason that's doing reset when I did that. I don't understand.
You just booted that same Bitsy Buy. I got to make a new disk because I want to put Bitsy Buy in with your test SP2 in it so that I can at least run that. Because I made the test and I booted it, but I don't think I see the drives.
Okay,
like you did. I just see RAM.
Yeah, let me try and get focused on what I'm trying to test here, which is this. What I can do is kill the connection, so it doesn't actually do anything. Then I can turn the listener off for now. Right, so I don't have a card in, and if I start this, then it'll sit there and it's not connecting because I have not got it. Oh, my cat! Oh, you move here. Sorry, mate. Right. Hello. Yes, I saw you. Tanya's gone up to some friends, so he's like, "I'm all alone. What are you? Why? What?" Right. So let's put some breakpoints on C500 and a breakpoint on the C508 and a breakpoint on C518. So C500 will be useful because that's the PR5 one. So now I've got these. I've now got this sitting there, and and because that's coming to the clean there. So now if I enable the listener, seems to be doing stuff in the background that I wasn't expecting. And then if I hit tab, why is that not interesting? It doesn't. It doesn't appear to be calling the thing that we're interested in at the moment, which is annoying.
It should enumerate you the devices. I mean, your disk devices, right? In slot, what? 7? Where'd you put your slip over SP in 7?
Well, it's slot 5 actually.
Oh, you put it in slot 5.
Yeah, it's in slot 5. So annoyingly, that is doing. This is all a timing thing. Come on. No, it's trying to disconnect. I think I've bugged that up a bit. Come on, just stop already. Close. No, you don't have to go on Wi-Fi. So all I really want to do is get this breakpoint up and get it to stop there. But what's the DOS entry point? So let me go back to that. I'm going to have to do some counting. I really didn't want to have to do some counting here. Actually, if I just boot it all up, presumably it'll be loaded and I can just look at it. So that'll do. Where's my... Oh, I've got so many things going on in my head. Right, here we go. Run FujiNet. Yeah, you've connected. That's fine. UC500. Are you even there? Yes, you are. Excellent. So this is the firmware. You can tell it's the firmware because the first 4 bytes down this list are 20.00.03.00, and they're just a bunch of CPX things. So the one that I'm most interested in is where the where it comes in to the driver. So this one where it does an LDA hash $00 and then does an immediate RTS, which is this one here. So C534. The C534, and it'll always be that because the firmware doesn't change size, equals the driver. And the C5, if we look here, oh, that's the ProDOS entry, and then 3 bytes later you've always got the smart port driver. So what happens in the network library is this card advertises itself through these bytes as a smart port device, right? Doesn't matter about slip, it's just, hey, look, I've got these 4 bytes, I must be a controller. And then what you can do, what it does is it goes to the last byte of the block, which right at the end, C5FF, tells it what the offset 34 here, that C534 is its entry point for the driver, which is the one I just wrote down, right? And then the smart port bit is 3 bytes after that. UC500, right. So we've got C534 and C537 is the smart port. SP equals C537. So what that allows me to do is to set up breakpoints on there and see which ones are being called. So if I do a breakpoint on C534 and a breakpoint on C537, then I've got 2 breakpoints on both those entry points. Okay, and I can F7. This will come into there, and it's hit here, so it's come straight in on Bitsy Buy, and it's hit as Oliver predicted. It would be C534. It's coming on the ProDOS entry point. So as you can see, all it does is say everything's okay and returns.
Wait, your firmware says everything's okay.
Yeah, it just sends a 0 back. So that's all it's doing.
Okay.
There's very little else.
That LDA right there on the right hand column.
Yeah.
Oh.
Which is also this thing here. So
wait, I think I sent an invite to Oliver, and I think he just joined.
Oh, okay, cool.
Which will be helpful because
hey, Oliver.
You're right in the middle of it.
Yeah, he's going to hear my ramblings now and think, who is this idiot? Right. Okay, so we've just got to the point, Oliver, where I can see your mic is muted, but I don't know if you can hear me. Hopefully you can. That I have loaded in the firmware into AppleWin. I've put a couple of breakpoints on the ProDOS entry and the smart port entry hit points, and Bitsy Buy booted up and it came in on the ProDOS entry as we kind of guessed it would. So all it's doing is that LDA #0 and return. So yeah, in the background, if I continue, I think. Oh, and then it's hit the ProDOS entry point as well. I will at some point have to work out
Hello.
where
Yeah.
the,
Hey. Yeah.
are you in the car? Oh, he's gone mute. Right, so for some reason it's now hit there. I need to be able to remember all the keys for AppleWin's debugger because I'd like to see what the stack is at the moment. 1F8, so there's at least 2 or 3 instructions there that are return. I think so, and actually this will go to the card, won't it? So that, and if I just RTS there, we can see that it's back somewhere, God knows, into 7.9, but it's not going to help me. Okay, so let's continue for now. And we've hit the ProDOS vector again. Sorry. Smart port. Is this going to hit 9 times? Interesting. I think that was probably hitting once for every time it had the disk up. Yeah, so I think it probably sent a bunch of requests through to every device. If I look at this now, it's all going to go wrong, but never mind. If I hit tab, that has come in on the ProDOS entry again. Yep, that's 8.0, 7, and it's hit it again, 3. So it went there 3 times. So we're definitely getting activity against that that vector. And as you pointed out, oof, that's bright. We've got the tech reference here. So I need to consume some of this and work out what's going on. So we know that we've got it vaguely set up, and the only reason I put LDA #0 RTS was it kind of made it work, which was good because it wasn't booting up previously when I was trying to do my network library. Now we want it to boot up and understand disks. I think I like your idea as well, Oliver, of using the AppleWin, just code on the card again. So just do more magic. So that there's less 6502 to actually write. So I was wondering, so all I need to do, I think, is understand what's going on this page and marry it with what the card needs to do. I know everything.
I'm sorry. Sorry. I was trying to answer a phone call and Apple just like exploded with devices. And I missed that second part. But when it goes and looks for that ProDOS, that's the operating system saying somebody's registered for something and you may be a bootable drive, right? And I'm going to go look.
Something like that. That's
you
the
can,
bit.
You can boot, right, at a low level.
Possibly. That's what I'm guessing. And that's
right?
why
It depends on what you return. Yeah, and you return that 0, which says
stuff
that your firmware will handle
potentially.
a boot.
It may
Right?
that OK may mean all kinds of things. I did stuff and everything was OK. Don't worry about it. It could be that I shouldn't be returning a 00 if I don't want it to act as something or similar. So,
well, read right there. Yeah, right there. If it finds a value, other than 00 FF,
this is
found
a
in
CNFF. So this is the high bit. This is the stuff I was telling you about before. So that one tells it where the entry point is, and if we look down here, I've got the value of the low byte of the driver. Link. FujiNet. Net. Blimey, what am I letting myself in for? So this driver value here is the low byte. We know that this is part of a single page, so you can always just put this byte in, and then whichever slot we're currently in is relevant to that one because it's CN plus this byte, and that byte just pulls in the low bit there. Oh, Oliver.
Hello.
Hello.
Can you hear me?
Yes, we can hear you.
Yes.
Okay.
Hey.
I finally managed to get the microphone working. It took me quite some while, but I made it. So yes, nice to talk to you.
You
after
too.
all those words written.
Yes, exactly. I know there's lots of it, but I absorb everything you write. So thank you so much for everything that you give me.
I know.
It gives me so much.
I'll throw that in too, Oliver. It's like I want you to, now that we're talking, it's a lot faster than typing. And I think you should just go forward and assume never, ever, ever that anyone is ever saying, like, don't keep making these contributions because they're very helpful.
Indeed.
I know they have more of an impact on Mark, but yeah, if anything comes back weird for me, it's 100% always just something lost in translation and never a critique, because I'm learning so much from what you're saying.
Yeah, thanks. Thank you for the kind feedback. It's really appreciated.
No, yeah, absolutely.
Yeah, unfortunately, I wasn't able to chime in the last minutes, and I was actually really trying to get my thing here working.
So no, shush now, shush.
If you're interested, can you maybe quickly repeat where you are standing and what type of issue you are right now having? Maybe I can assist you somehow.
Yes. So what I was finding is I put a breakpoint in here.
Can you make it a little bit larger, because for some reason I have only a very small screen area with video, because a lot of things are around black border and I still have no idea how to
it is true. Like, you have to make it as wide as possible. I'm wondering, Mark, if you could just in Visual Studio Code bump up the font size. I feel like the Apple II Win screen, I could see that. Can you see that, Oliver? It's the code that just turns into little pixels.
Yeah, no, but in the debugger, I unfortunately cannot make out the line or the characters that are currently displayed. And I would really like if I knew how to enlarge this, but thank you. Now I can read it. Great. Yeah. Thank you.
That's it. There's a big button down the side that goes full script. Unfortunately, it doesn't seem to have a setting in between. So let's see if I can Alt Tab. Yeah, I can Alt Tab between. Right. So
okay, great. So now I can follow.
Right. So what I was teaching Andy was how the page for the bytes work, and how there's a driver byte at the end of the page for C500. That's the slot it's in, and that it would load into there. And I've put breakpoints on 34 and 37, which was the ProDOS entry point and the SmartPort entry point. For some reason, it's gone again. So I don't understand why sometimes. Has it unloaded?
So 34 is ProDOS and 37 is SmartPort, right?
Yes, that's it. So ProDOS entry point is getting...
And right now it hits the ProDOS entry point, right?
Yes.
Yeah, and that's what I assumed that would happen. And if you read the documentation, this API works basically mostly with zero-page parameters. So by the time this thing is hit, you see in the zero page on certain fixed offsets, 43, 44, 45, somewhere around there, you have the parameters of this call.
Yeah.
And when we quickly look up the documentation, we can maybe just at this one call find out what the call wants from you. And then you can maybe see what what's going on. Very, very likely the very first thing it does is a check call, a status call, where it tries to find out is this device it asks about, is this online or not?
Yeah.
And it wants to see as return values, yes, this device is there, and if yes, the X and Y registers should contain the size
Yeah.
in blocks, and then the accumulator would be 0 and the carry would be clear. And if you say no, this device is not there, you would say accumulator is, I think, 2B and carry is set. And then X and Y are of no meaning. That would be basically your API.
Okay, doke.
And this is the type of thing how it works. You see it. I think you have these command and A command is, I think you see 42, right?
Yes, it is.
It's very small for me to read.
All right.
42 is the command. So when we right now look at the debugger, in the debugger at the location 42, we should see maybe 2
it's
is
no 1. Yeah,
it's 1.
It's 1.
And when we now look up the documentation, that chapter 6.3 in the Apple and the Protos reference manual. Yes, yeah, here we are. Then you can see that you have, let's see, the commands are call parameters, commands.
There we go.
There you have it.
It's a
42
read.
command. Read.
Excellent.
You see, it does a read command.
That's exactly
This
where I
is
needed
now
to
how
get
you.
to. And then the volume.
Okay.
Yeah. So then we've got the unit number there as well.
Yeah. Let's look at the 43. What it says.
Which is this byte here, D0.
Yeah, that's great. Yeah, D is basically D is the slot.
Yeah.
And you see the slot is from bit 4 to whatever. So if you just
1101
the low fork you can
0000. So D0 is 1101 in the high bit, which is DR set, and then it's 1, 2, 4. So it's 1 and the 6. So that means DR plus the slot number is 5. That's DR5.
Let me see with I.
Yeah, that's slot 5.
Okay, so that makes sense, right?
Yeah, exactly, because we are seeing for this one.
Okay,
it's
you
slot
see,
5.
and it has and then there's an additional bit for the drive.
Yeah.
Because there are 2 drives. It could be 0 for drive 1 or 1 for drive 2. And this bit is 0. So it's looking for drive 1. It's trying to read something from the first drive of slot 5.
Sorry, was DR is set here because the value is D0, so it's above 8.
Oh, then okay. Then it's drive 2. Then maybe you have already tapped over drive 0 and are now at drive 2.
Yes, I think I was tabbing a few times, so I would.
Okay.
So 0 equals DR drive 0.
Sorry, I. Okay, and then you can go on and see maybe the sector, the block that it tries to read, and then we would maybe find out that it tries to look at a directory block or something like this in order to bring out a listing of the root volume.
Blimey, we've got a whole bunch of people in. Hello, Tom. I don't know your real name, Linux HA. Right. So yes, we are seeing that it is a disk read, and we are being told what the value is. So that's cool because that means we can now interpret that by reading that entire 0 page. Neil Cherry, hello Neil. We can interpret that correctly, and then we can go off to the FujiNet PC and expect that to be that drive. So why
Yeah.
is there only 2 drives?
Sorry.
So we've only got 2 drives. How does that map to
Yeah.
the fact that we want, say,
Okay.
we could have
Mm,
6?
yeah, this is all about backward compatibility. When the Apple II was introduced, you had this disk 2 controller, and on the disk 2 controller, you could have 2 drives. And then it started to become popular or normal that on one slot you have 2 drives. And then things started to say, okay, I could also have a hard drive controller, not a disk 2 floppy controller. But they stayed with the idea that the controller has 2 drives connected to it.
Okay.
And later on, the first Protos versions can only deal with such things. The first Protos versions have no idea of a smart port. Only later Protos versions have that. And to retain the backward compatibility of such a smart port controller with, for example, an older Protos, every smart port controller emulates, if you want to say, also an old Protos controller. And therefore, you are supposed to always implement the old Protos entry point as well. And that old Protos entry point can give you access to 2 drives with up to 32 megabytes. And that is, yeah, basically the backward compatibility. If you have, for example, 4 drives connected to your smart port,
Yeah.
then the first 2 drives are available to old software that only knows about 2 drives, and newer software can access all 4 drives. That's the whole idea. And as far as I understand, because Protos started out with these older things, I believe that it works like, and additionally, Protos has the thing that the internal data structures are all around slots with 2 drives. So you have already seen maybe when on an Apple IIc where this all already works nicely, that when you have, for example, FujiNet with 4 drives, then the first 2 drives are in slot 5, and then the other 2 drives are mapped somewhere else. And this is this remapping that is done. And my understanding is that the first 2 drives that are not remapped are, as far as I understand, always accessed via the traditional Protos entry point, and only the additional remapped drives, I believe, are ever accessed via the smart port entry point.
Right.
That's my belief.
Okay. Right.
Does that make sense somehow?
Yes, no, that's absolutely. I'm absorbing. This is. I've also doing a cycle. I've just done a cycle. I think I went past the 2 RAM drives, and what I wanted to do is see what happens next. So this is now a read. We can see that 42 is a read again, and then 20 is obviously high bit. So that's drive 2. No, that's
I
slot
think,
2, drive 1.
yeah, I must admit that I have no idea why it. Yeah, I would presume that by returning with the accumulator 0 to former calls without having basically filled the data structures or without returning the right values, you already messed up the internal Protos data structures completely.
Yeah,
And
that's
therefore, everything that happens now is already bogus.
Oh yes, absolutely. It's interesting to watch the data as it comes through, but yeah, I couldn't understand why.
I think this is likely not supposed to ever happen.
Yeah,
That it comes into the old Protos entry point for slot 5 with a drive that is supposed to be in slot 2. That doesn't make any sense.
yeah.
It should only try to access the slot 2 stuff that is remapped via your smart port entry point. So I believe things are pretty messed up.
Yeah, I'm not. I'm. Yeah, I get that because we can see that this is coming in with AO, which if we knock off the 8 on 10 is 2. So again, it's the drive 2 on slot 2. So yeah, that's drive 2 slot 2, and
Yeah.
we can F7 that. We're still there, and then yes, there we go. Look, S2 drive 2. Now we've hit S6, which is that again. That's interesting. Why is it saying S6 not? But it's on slot 5.
Yeah, it doesn't make sense. It should not happen.
All right. But that's good. Well, I now know where the data is that I need to read in order to work out what's going on.
Yeah.
So these...
in general, this works really great with the way you implement this in AppleWin, because you see you have fixed 0-page locations with your parameters.
Yeah.
You can just go from the AppleWin code, just to look into the memory from within AppleWin and grab the parameters. That's exactly what I did for this Neo 6502 emulator, where I showed you the code from.
Yeah.
It's just when you look at the code, I think is it the code from my thing?
Yes. I completely.
If you
oh, this one isn't but yeah, I did exactly the same. I'm doing magic and storing it in one value, and then in AppleWin.
The only difference is you can even do more magic, because, as I said, return values are in registers about success or failure. And because this machine I was working on has a real 6502 combined with a virtual environment, I cannot set the registers so virtually. Therefore, I have a little bit 6502 code that just says, okay, just read the registers all from these memory locations when you're done. But with the AppleWin, you can, of course, manipulate the registers right away. So there's basically no need to execute any 6502 code in your driver at all. Basically, I would say it's just the same idea that you have already for your smart port entry point. It's just a little bit simpler, because there are way less, let's say, indirections and, oh, look there where the pointer is of this, and then you need to dereference this pointer to get this data structure. It's just totally plain and flat. It's very simple.
Yeah, because all the stuff to do with smart port, this is what this is doing. It gets out the register's stack pointer address and manipulates them, adds 3 to it for the return.
I see.
And doing all that kind of stuff, and then at the end specifying
that's
the
the type of stuff I would expect here.
Yeah.
I see. And you can do it in a similar way, but you will see that it's only, let's say, like
reading 43,
20% of the code you need. You just read some 0-page variables and you already have it, and you just return, you put some stuff into registers, and that's basically all. And
so I should be able to so I'll interpret something like a status, and I can send a status request off to the disk, to the FujiNet disk. I'll get a read, and I can just do a read of 512 bytes and shove it straight back into the buffer that it was expecting it to do.
Yeah, basically that's what other firmwares do as well, but they do it in pretty complex 6502 code. What usually is done, that you say the smart port interface is, of course, a superset of the old Protos interface. Therefore, people usually map the old Protos interface internally on the smart port interface. So basically, people create a smart port call on the fly from the Protos call.
Yeah, and that's what will happen.
And you can easily map. You can see basically what the Protos interface wants is the disk there? Is the read is it writable or is it read only? How many blocks do I have? And then please write a block or read a block. Basically, that's what it's all about. And you can clearly see to which smart port calls you want to map those things. So the first is of course this I don't know, the get status. No, you know it, of course. The status request, exactly. You have the status, and you have the block read and the block write.
Yeah, which
and
were
these are the 3 calls. Yeah,
conveniently at the top, which were the first ones you wrote. This is perfect, and all of these obviously.
That's the point. And you need to make sure that you create those calls from the PRODOS entry points as well, in the same way you create them from calls to the SmartPort entry point.
Yep. And here,
And
I think.
yeah. And the only magic, basically, therefore I wrote it already in the forum or in the chat. The only magic is about the drive numbers, and that's I think it's pretty clear. I'm pretty sure that it's that way, that the first two block devices.
Yeah.
The block devices, when you initiated the code, the whole thing, and the block devices answered, and you assigned device IDs to them, the first two block devices that answered, and you gave them the lowest device IDs. Those are the two block devices that should be connected or requested when PRODOS asks for drive 1 and drive 2.
Okay, cool. So when we go into, for instance, here, is this up? Is this up? I don't think this is up. Just a second. Oh, it is. It is. So this is the FujiNet PC web interface. If I put in disks in here.
Can you make it a little bit bigger, because
Yeah.
I cannot see any,
Yeah, no
and I
worries.
still don't know how to better do it here locally.
That's all right. So we've got the hosts list. Oh, I've got a fly on my screen.
Yeah.
And if I click on SD, I can see that I've got a single disk on my TNFS server called test SP2, and then we can mount it to our drives. In FujiNet world, it has 6 drives. So I think what we're going to see is that 1 and 2 get mapped to the PRODOS 1 and 2.
Yeah,
Right.
it would be strange if the mapping should be different. There's no good reason for the mapping not to be that way.
No, exactly.
In the Apple IIgs, in the Apple, what I'm saying now is something where I'm not good at. Therefore, but I think the problem is like this. Every time a SmartPort controller initiates these things, the devices answer basically in the same order. And this gives you already the boot order, because booting is always done from the device with the lowest device ID. So what is if the user wants to boot from one of the other devices he has connected to his SmartPort controller? My understanding is that on the Apple IIc and everything else 8-bit, there's just no way. If you want to boot from something else, you need to rearrange the physical connections. You need to rearrange the physical daisy chaining, so to make the devices answer to the init request in a different sequence. But on the Apple IIgs, there's in page E0, I think, an additional mapping.
Okay.
And there you can basically remap the physical SmartPort devices to the order in which they appear to the SmartPort interface. So you can there somehow, influence, for example, which device is the first one and therefore is the one that is booted from. But this is, from my understanding, something specific, very seldomly used, and only available on the Apple IIgs. So taking this apart, I would say it's always straight one-to-one.
Yeah.
I would presume what you see as in the first slot in FujiNet, and the second slot is supposed to end up as devices with the lowest number, and therefore are the 2 drives available to the PRODOS interface. Would be my assumption.
I definitely believe, Oliver, yes, because on the Apple IIc, if you buy that floppy EMU, there's a special adapter that they sell, right, that has a physical switch that swaps out the internal drive to 0. So I think you're right? It's all locked in. And also, to me, it's not that big of a deal coming from the Atari world, where the Atari only ever boots from the first drive, right? So there's no chance that anyone's going to try booting from any other drive. It just makes sense, right? That drive 1 is going to be where you boot.
I think what you say about the Apple IIc is maybe a little bit something different, because it's about the 2 drives that are connected to the internal disk 2 interface. And this is obviously a total physical thing, because it's always like on a normal Apple II Disk 2 controller card, the upper connector is always drive 0 and the lower connector is always drive 1, or sorry, drive 1 and drive 2.
Okay.
So it's really
Okay,
like
so
a
that's
physical thing, and you never change it. And this adapter really changes basically the wiring of the virtual Disk 2 controller in the Apple IIc. While with SmartPort, it's
yeah.
really like you have a lot of devices, way more than 2, and there needs to be some software defined mapping to the old traditional drive 1 and 2 thing. And there it's only a question of how much software is there that allows to do a remapping. So there it's always a software thing and not a hardware thing, while on this Apple IIc thing that you mentioned, it's more like a hardware
It's the
question of
hardware.
the disk
All right.
2 drives.
That does make sense.
Right. I've got a question. This is aimed at what are the 4 disks that I see here? So these are the 4 disks that are advertised by the smart port. So normally, obviously, all the network library goes via the network. So that goes and does the thing. Are those 4 disks meant the things that config will mount to? Is that what they represent? Do they represent the disk that you pick in config that will then say, I am 0, 1, 2, and 3? And then first 2 we would map to ProDOS disk 1. Second one we mount to ProDOS disk 2. We would say, hey, I got a request for disk 1. I'm going to put it through to FujiNet disk 0 here. Is that the connection?
I'm not 100% sure that I get your question right.
Yeah, I think the slots. Like jump to that picture of the web page, Mark. I think those FujiNet disks that you see there, 0, 1, 2, are the slots 1, 2, 3, 4. Like go back up a page to the main. Hit that. Yeah.
These.
Right. It's those slots. Yeah. 1, 2, 3, 4.
Okay, because obviously we end up with. I know I haven't run it recently myself, but when we look at config on Apple, it's got 2 sections, right? It's got kind of a disk section below and a section above. So I don't understand what those are at the moment and how they map to these things.
This is basically also FujiNet is still so new. This is all already, let's say, legacy. And it should be different. But anyhow, the idea is that the 2 things below are disk 2 drives, and the above are SmartPort drives.
Right. Okay.
And
my
understanding is this: on the physical bus, the physical wire that comes out of, let's say, an Apple IIc, you can connect both SmartPort devices and traditional disk 2 devices. And the SmartPort devices need to be in the front of the daisy chain, and the disk 2 devices need to be at the back. And the idea is that on this single wire, the machine can access both disk 2 devices and SmartPort devices. The point is that although the physical wire is shared, the whole interface on the Apple II is totally separate. The disk 2 devices are always, let's say, accessed by some specific WOS logic or the integrated WOS machine, the IWM controller, which puts this together in a single chip. So there is a very specific hardware that is designed to drive the wire in a way that it works perfectly with 2 disk 2 devices. And then the extension was made to say, okay, and we can use the same wire, we abuse basically the same wire to say now we are using it to send abstract data packets back and forth instead of single bit values. And then it switches into basically a different mode, and then the same wire becomes the smart port wire interface, the C bus. And then it's driven by totally different chips and different ways and
different
different
logic.
firmware interfaces.
And
And
yeah,
therefore, sorry, and therefore, in order to use both disk2 devices and smart port devices on the same bus, you need two types of firmware sitting in two slots. And this is basically what the Apple IIc does. This is what the Apple II GS does. And this is something a lot of persons don't get and understand well, that if they put in, for example, into an Apple IIe, a nice smart port card, like a Lyran card or a Yellowstone card, and then put FujiNet on the C-bus, then they will not have access to the disk2 emulation of FujiNet. FujiNet can emulate both at the same time smart port devices and disk2 devices. So what it emulates is like having, like, for example, 4 smart port disks sitting on this daisy chain, and then having additionally at the end sitting 2 disk2 drives at the same daisy chain. And so it's great that it's emulating all those devices, but on the Apple II side, you need to have the right firmware and the right stuff to control all these devices. And as I said, in order to do that, you always need 2 slots. And no matter how magic or how clever your card or whatever is, the point is that as soon as you want ProDOS to understand and mount those things and integrate it into its device list, you need to have 2 slots, because ProDOS is just not clever enough to understand that a single slot could contain both smart port devices and disk2 devices. It just cannot do this. It presumes it needs 2 slots, whatever C5 and C6 in firmware. So you always need two slots.
I think it's a complication, and you're talking about 2 things. So when you look at the window right now, Mark, on that web interface, what's happening now is no one's taken the time to customize this for Apple. This is the default Atari one, which has 8 disks.
Yeah.
So you can forget about the web page. Is simple. Someone needs to go in there and just knock it back to 4, right? And that's all you'd ever see. And everything that Oliver said, I'll just tack on some more, because what he said is correct. It's like those 2 disk 2 images, right? Those are capable of reading the WAS Flux images directly. You know, you don't have to have like an image, like a PO. You can take a Flux, right, that someone created with the applesauce or something, and load that right into those 2 slots. Because as Oliver said, it's like talking a bit stream directly to the IWM that's emulated, right? And that's what Jeff Piepmeyer did, right, with the whole RF. He treated it like a remote control, as like a thing. But in my opinion, I think as we move towards releasing this for like regular people to use, my personal opinion, nothing else, is that we should jettison that whole thing of the disk 2, because I think it's needlessly complex, creates confusion, and there's a whole bunch of caveats. Like, you'll never be able to write to that. It's only ever going to be read only. And it doesn't do block commands. It has to read the entire Flux into memory in the FujiNet, and then it can boot it. So it's like a really cool technical experiment, and maybe there's some reasons to have it under like super advanced options, but I think the whole thing should be cleared away, and certainly it may not be something we want to look at certainly now, just to get the virtualization off. You know,
I must admit that I totally agree with you. I must say, I'm not as seeing me not as a, let's say, a core member of this project. I would not have dared to say this, but I'm totally with you. I think all disk2 emulation is a super cool stunt, but it's really a super cool stunt. But I feel that the complexity coming from it, from user perspective, understanding which types of images can go where, and why sometimes things work and not, and why are sometimes images suddenly read-only, while when they put the same image somewhere else, it's read-write. I understand this, but the usual owner does not understand this.
Right. So Tom, let's have
My
Tom have a chat. Just a second. Tom's unmiked himself.
Okay, first of all, I agree with this. It's okay.
Wait, Tom, you sound really bad. Are you on some funky microphone or something?
Sorry, all right, so let me try to my good microphone. Sorry.
I can't even
No,
understand what you're saying exactly.
Yeah,
yeah,
sorry,
sorry, I
Tom.
can't understand anything.
Yeah.
So just a
Yeah.
little bit more of I don't know what Tom wants to say, but nevertheless, I'm saying what I think. My personal guess would be there are machines like, for especially the Apple IIc. In the Apple IIc, we have the problem that the SmartPod controller is fixed in slot 5 and the Disk 2 controller is fixed in slot 6. And when you don't use something like ROMX, which allows you to modify boot order and whatever, you always have the problem that the machine wants to boot from a disk 2 and not from a smart port. Every idea of accessing a smart port requires you to boot something and then enter PR image 5.
Yeah.
And we could, it's my personal thing, we could use the disk 2 feature in a great way to make this better. To say, the default thing is to boot into config. I will implicitly mount the config disk not only into the first drive of the smart port, I will implicitly also mount it into disk 1 of slot of the disk 2's thing. And when you this combine with this adapter we talked about that replaces drive 1 and drive 2 of the disk 2, which allows you to boot an Apple IIc from an external disk 2 drive, then you can auto boot into config on an Apple IIc. And the interesting thing is that the config never needs to write to disk. So my guess, or my idea would be to say the idea of the disk 2 is nothing we expose to the user in order to let him mount disk images there because of the complexity, but we might use it internally to allow to auto boot from a disk 2 by loading the config from a emulated disk 2 drive if the disk 2 controller happens to sit in a higher slot than the SmartPort controller. So we can just cold boot into config on such machines. And this might be a nice use case for this whole technology, and there no complexity for the user and no problem with not being able to write. And additionally, the config itself is very small. Recently we changed it that it doesn't even boot Protos. It boots basically right into config. That means it loads maybe just 20 sectors or something like this, or 30 sectors. So the lower speed and whatever doesn't hurt. And we don't need to load a full WOS image into RAM because we already know that for config we only need the first 2, 3 or 4 tracks, and the other 30 tracks will never be read anyhow. So this would be something I personally would consider pretty cool, and to leverage the technology invented.
And can you guys hear me better now?
Much
I'm on my
better.
good.
Oh yeah.
Yeah.
Great,
Okay.
great.
Okay.
Hello. Hi. Nice
Oh,
to
hi.
talk to you.
Hi. Okay, so, all right, first of all, I agree with this line of thinking completely. This is a good example of enhancing the user experience and making everything just appear to work. I have no issue with basically hiding the disk 2 functionality. The only thing I would probably say, if we could possibly do it, maybe not, if someone selects a WAS image, it goes to the disk 2 slot, hidden disk 2 slot. We just go, okay, we're going to boot that. We don't ask them anything. We'll just throw it in, and that'll be, you'll boot that, because 9 times out of 10, somebody's going to try to take and toss a WAS image of a game in and expect it to boot. I don't know, maybe not.
Yeah, well, when Mark does the assembly language version of the Apple II config, I will put that down as one of the feature requests.
No, a lot of what you guys have been saying the last 5 minutes or so, I need to listen to about 10 times to absorb. Obviously, my Apple II knowledge is only started around October, November last year, so some of the stuff I need to see and absorb, definitely. What the fundamental part for me is definitely getting those 4 entries there in the smart port are the disks that we need to mount.
Yeah.
And we'll use the network device for doing HTTPS and all that kind of stuff, and also connecting to the TNFS drivers ultimately, and then we just mount those on those drive slots.
Yeah.
That's
And as far as just one little bit of commentary, yes, I know, Oliver, I know you were surprised that we actually attempted to do this in the first place. The only reason that we attempted to do it in the first place, or more specifically, the reason that Jeff attempted to do this in the first place, was that we were just ignorant and crazy enough to try and do it.
Yeah.
We would not know if we knew what we know now about the I want to use much stronger words here. The rather unique architecture of the Apple II in the first place, I don't think we would have done it.
Yeah, I think maybe it's causing if we look now how hard it is for persons, even the ones that are close to FujiNet, which are really far from being end users, how much trouble people have to get through all these slots and drives and types and image types and all this mess. I think people get lost.
Yes.
And then additionally, it was pretty clear from the start that writability would not really be feasible. And then additionally, unfortunately, this whole let's say abusing the remote control peripheral makes it a little bit maybe hard to move forward to the ESP32S3. So if we all put this together, maybe the effort spent for this feature was not the greatest spend.
Hey, we learned something from it, so it's okay.
Yeah, for sure. And hopefully it's fun. It was fun for someone to say, I got it working. And then it's great, of course.
Seriously, we all need to take a moment to thank Jeff for literally doing, if it wasn't for Jeff's efforts, literally during the last part of 2022 and into 2023, there would be no Apple II bring up. And he has some extreme talents in this area, and the fact that he was able to put together that we could abuse the RMT macro block to actually pull off the disk2 emulation is that's honestly amazing. With that said, we'll try to we'll try to expose it to try and make it easier to boot on some of the other Apple II units. But yeah, other than that, let's put it away from most users' eyes. That'll solve a lot of problems.
Yeah, I think that therefore you can imagine I've been thinking about this quite a bit, and at some point I felt that really I'm now repeating myself that this using it to bring config into RAM in scenarios where otherwise you would not be able to bring config into RAM that easily. That might be a great usage for it, because you don't have the complexity.
It makes perfect sense.
And the read-only thing is not a problem there. So it feels like a natural, cool feature then.
I'm all for it. Make it so. Let's try it.
This is great. This is we've gone from the virtual fully back into the kind of future of the real hardware, and I love it because it is absolutely where I need to get my head to understand any of this. It's funny, when I came to this with the Apple, it was just like, oh, I'm writing a network library. Let's just have some fun with this. And obviously, been over, picked up an Apple II, written a extension to the emulator. For me, when I first came to the Apple II side, I thought it was a lot more mature than you guys seem to be making it out. But I'm having a lot of fun with this, and I think it's a really good target.
I'm glad.
And welcome, Willie. I think he's he's not muted, so maybe we'll get some hello from him as well at some point. Right, so we have, this is good. So what we understand at the moment, the kind of the beginnings of this conversation was why is the disk not booting very well, and that's probably because we haven't done anything here at all. So
Yeah.
I've got the ability now. I know where it's coming in. I know what values to look at because. Also, I've been looking at all these different examples. The one that's in AppleWin itself for this HDD controller uses all the same bytes. So I kind of assumed that something similar was going on here. So it's good to get your confirmation on that and to actually actively see it working. And we've got a spec to work against as well that we can read on that. So,
so you have the spec, you have several examples. You can easily see that they are very similar when it comes to the point.
Yeah.
And additionally, as soon as you have this working, then additionally have it boot and auto boot is not a big deal, because the point then is, is it okay if I quickly explain it right now, or?
Go for it.
Okay. The point is basically there's a very, let's say, simple specification that says that booting from a device means to load from the first disk, load the block 0 into memory at address 800, and then jump to 801.
This stuff.
That's basically the protocol. You can see it here. And you can make this a little bit nicer with some more additional checks. And you can see this, let's see, where are we? The Protos, Protos, how do you say?
This is this is the code.
This is from this emulator, right?
Yeah.
This is the code I would use from your perspective.
Yeah.
I don't want to boast, but I think my code is really best, so it takes all the things into account. I've read these type of codes from a lot of implementations, CFFR 3000, Booty, whatever. I've read and some reference implementations, and I think I've really understood what the points are. And so you can just grab this code and plug it in, and you are done. Basically, what this code does is it builds up a simple Protos driver entry and calls into the Protos driver entry. And as you see, in order to do this, you need the Protos driver entry being there and usable. And therefore, it's surprisingly not the first step, because without this boot code, you can already access the devices when you boot from something else. Because for Protos to find the device and attach it into its internal data structures, this booting is just not necessary. It's an add-on. And I wanted you to first check out this Protos driver entry thingy and get this working. And then afterwards, you can just add this boot logic to it. And then it will also work with saying PR image 5, or if you remove the other drives, it will write cold boot into your emulated device.
Yes, exactly. Your steps 1, 2, 3 that I took step 2 straight to be the first one that I should do, because I'm not a beginner.
And if you can even, if you're interested in it, you can even go, let's say, fancy and say, I now move my emulated card from slot 5 to slot 7 and remove the hard disk that is currently in this virtual slot. And then you can see how it boots your devices. And if you, for example, don't have a FujiNet connected at all at the TCP connection, it should understand this, because it fails to boot from the drive. And then it continues the slot scan and will try to boot from the virtual disk 2 in slot 6. And yeah, it's not really important for this AppleWin scenario, but it should work.
Excellent.
Because the code that you see has these additional features that I mentioned today in the chat, that it distinguishes between being called by the user,
Yeah.
entering PR image, whatever, where
Yeah.
you want to have a reaction, a fault reaction of an error message,
Yeah.
versus the ROM auto boot, where you, if something goes wrong, want just to try the next slots and see if they can boot. And yeah, that's basically a little bit a cool feature of such a ROM to distinguish this cleanly and support both use cases correctly.
Excellent. Right. So I have something that I can progress on the AppleWin side to get that, because I'm obviously doing the talk over at VCF East, which I was going to base on our work here, the Apple emulator, why it was needed, the network library. So I want to have something that's visual from the AppleWin point of view, so that we can boot into FujiNet and actually have a little play with things. So it'd be really nice to get config and some disks working. So that's why I kind of want to focus on that rather than the FujiNet IO for Apple at the moment. Selfishly, because for the demo that I'll be doing. But
yeah, I see. I'm pretty confident that it's not too much work to get this going. I'm pretty confident that is feasible.
What's nice about this is the feedback loop is so quick.
Yeah.
Some of the stuff that I do at work, it's you press a button and you have to wait 3/4 of an hour before the pipeline's finished before you'll get a failure, and then you have to. Today I lost about 2.5 hours to pipeline failures, whereas this I can very quickly boot up, run something, see what the bytes are, play around with it, and the feedback loop is really quick. So that really helps.
Yeah, and that's basically the reason why I'm still not decided if I will try to leverage all your work on the AppleWin side for my A2 RetroNet development in order to simplify my development there as well, or if I will try to get through with pure
hardware.
Hardware. Because the initial step to somehow visualize the hardware in a way for AppleWin is not let's say trivial, because it's not trivial. We don't need to get into the details. It's a hard decision, but I really see the point, and every time I have something visualized enough to be able to use AppleWin with its debugger, it's a whole new world towards trying to figure out what goes wrong on the real machine without any monitor and debugger.
Well, if you've used the Linux version of it yet, it's even nicer. The Windows that you can use, the Linux one uses IMGUI, IMGUI.
Oh yeah,
I
like it. I like the Linux version. It looks much cooler.
Yeah,
and it's interesting that it's interesting that it's so super unpopular. Every time in every channel someone says about it's a bad thing that we don't have AppleWin for Linux. I say there is AppleWin for Linux, and then everybody says you are stupid. It's AppleWin. It's not Linux. I'm not talking about wine. And say no, there's a native Linux version of AppleWin.
Exactly.
And then I give them the URL, and then they say, wow, it's cool, but for some reason it's not getting popular.
And yet it's off the same fork, because that's what I did with the code. It's just all the same. I just set up repositories, remotes between them, and pulled changes across. And that's how I got that's how it came up so quickly. The SP over slip stuff just copied straight in, and virtually no changes. And it was up and running.
Yeah, and that's a cool thing about it. And it doesn't come. It's the explicit, let's say, goal of the person who does that AppleWin for Linux to keep his code always compatible with the AppleWin code, so does it works this way, and therefore everything that he needs to be a little bit different or a little bit abstracted for Linux, he successfully upstreams to the original AppleWin repo. So it's not like some, let's say, anonymous fork. He is in close contact and in close collaboration with the original AppleWin development team. And and I have been helping the person doing the Linux variant with emulating the Ethernet 2 card. So I've been working with him on this, so I know him, and I know therefore let's say the whole project setup.
Yes, I've seen your name across almost everything I ever Google on Apple II has usually got your name somewhere on it.
Yeah, the years, all those years add up somehow.
Right, excellent. So,
okay, great.
This has been a really good chat. Thank you, everybody.
Yeah.
And let me finish for me with saying that I really, really, really appreciate to be talking to someone, because me, it's so many years always only writing and so little personal contact. So I really enjoy this a lot.
Good. Yeah. Well, we'll have to keep it up because these sessions are super valuable, at least to me. I just get to glom on and pick this stuff up. And it's so easy with our technology here. We're usually in this typing so much. And I always say it's like too much to type. Like we can speak and save a lot of time.
Indeed.
Trying to type it all out.
Actually. Yeah, exactly. As you say. So, yeah, thank you.
All right. Yeah. Thanks a lot, Mark, for jumping in and kicking this off.
That's all right. No worries.
And Thomas, thanks for having the first personal talk with you in this chat.
Likewise.
Okay. Yeah. Bye then.
Right.
I think I need to run for dinner.
Bye-bye.
Okay.
All right. Cheers,
Bye.
everybody.
Bye-bye.
Later.
Later. And I will call it there. Oh, my mic. Yes, my mic is working. Good. I think that all came through. Discord was there, so hopefully we'll be able to play that back with my face in the corner. That really helped. Yes, cool. Thank you very much. Bye.